Hello guys, welcome back to my YouTube channel. Myself Nikhil. Today's subject is mathematics and the topic is ANOVA techniques and basic principles. ANOVA techniques and basic principles. Analysis of variance. ANOVA is a powerful statistical technique used to compare means across multiple groups. Introduction to ANOVA. ANOVA is based on partitioning the total variation of data into different sources of variation, testing differences. It helps determine if there are significant differences between the means of two or more groups. Variance components. ANOVA compares the variance within each group to the variance between groups. F statistic. The F statistic is calculated to assess the significance of the difference between group means. Fourth, null hypothesis. ANOVA tests the null hypothesis that all groups means are equal. Assumption of ANOVA. ANOVA relies on several assumptions that must be met for the result to be valid. Normality. Data within each group should be normally distributed. Homogeneity of variance. The variance of the groups being compared should be equal. Independence. Observations within each group should be independent of each other. One-way ANOVA. One-way ANOVA tests the difference between means of groups based on one dependent variable with multiple levels. Step 1. Data collection. Collect data for the independent variable and dependent variable for each group. Step 2. Calculate F statistic. Compute the F statistic based on the variances within and between groups. Step 3. Interrupt results. Determine if there is a statistical significant difference between group means. Interrupting one-way ANOVA results. Interrupting one-way ANOVA results involves assessing the F statistic, p-value and effective size. F statistic measures the ratio of variance between groups to variance within groups. P-value, the probability of obtaining the observed results if there were no true difference between group means. Effective size indicates the magnitude of the difference between group means. Two-way ANOVA. Two-way ANOVA investigates the interaction between two independent variables on the dependent variable. Main effects. Tests the effect of each independent variable on the dependent variable separately. Interaction effect. Evaluates whether the effect of one independent variable on the dependent variable depends on the level of the other independent variable. Interrupting two-way ANOVA results. Interrupting two-way ANOVA results involves analyzing the F statistic, p-value, and effect size for main and interaction effects. Main effects. Determine if each independent variable has a significant effect on the dependent variable. Interaction effect. Assesses if the effect of one variable is influenced by the level of other variable. Practical applications of ANOVA. ANOVA is widely used in various fields to compare means and understand the impact of factors on outcomes. Healthcare. Comparing treatment effectiveness in clinical trials. Business. Analyzing marketing campaign performance across different demographics. Education. Comparing academic achievement between different teaching methods. Science. Examining the effect of experimental conditions on research outcomes. Limitations and considerations. While ANOVA is powerful, it has limitations that need to be considered when applying it. Assumption violations, sample size, outliners, data transformation. Conclusion and key takeaways. ANOVA is a valuable tool for analyzing data, comparing means, and drawing meaningful conclusions. Understanding the assumption and limitation is crucial. Proper interpretation of results ensure valid conclusions. ANOVA can be applied to a wide range of fields and research questions. Thank you. Please like, share, and subscribe.